Okay, and that's, I think, like one nice follow-up would be also to do a kind of this comparative study where we look at cluster MMS and other types of data and try to benchmark PMMs, or which some of the work was done, I guess, already by you, Wiki.
Yeah,
some of this type of.
we were trying to then extend to cluster, and
Yeah.
had one proposal to do such.
Okay. Yeah.
Yeah, and one other thing for, I mean, if you want to compare different missions, usually the difference between the instruments is the time resolution.
Yes.
But you can always sum data to bring them to the same resolution, and then you have very, very similar data.
But there are also machine learning models that they are doing instrument-to-instrument translation. So I could imagine one could also try to do such thing, also do in situ. Probably it can happen. If you have a lot of data that can be compatible, you can train on that.
Yeah.
Then I don't think that there's no reason to do that.
Because I think usually it's 4 seconds now for cluster, the resolution, typical resolution, it's the spin. Classification of region could be done with maybe 1 minute resolution. So you can really like reduce the input data a lot. The guys who are clicking, they could see minimum 1 hour on the screen. They could see the difference between regions, so they didn't have a 4-second resolution. They had less.
Yeah. And since now we have this open discussion panel, so anyone can actually have a remark and can initiate a bit of discussion. I have one remark from your presentation that actually it's a nice use case where we have a model that is been mostly human oriented, and we have a, let's say, very general machine learning model. So we can see what the community needs, and we can enrich the machine learning model and come and meet more specific needs of specific community. So I agree we should at some point keep the human in the loop, but sometimes it can really save costs. It can really accelerate things, and I mean we can be flexible and design the tools after some interaction with the end users towards more, let's say, practical tools.
That would be very useful, like end users like me who know nothing about machine learning and classification like this.
Yeah.
We understand it will be very useful and powerful, but we won't develop it on our own. But we can express the need,
exactly.
Things that are important, things that we don't care of. Or...
We have in a different project, we try to have these meetings every 6 months, 1 year, where we try to have a panel of potential end users of such a tool, and we try to receive some feedback how at least the interface, the high-level interface, such a model, the output, or what are going to be the needs. So to try already as when the machine learning model is under development, to adapt a bit the output towards the needs of the community. Because otherwise, yes, we as the developers might build a machine learning model to do something else, and there's a community have different needs, and then they don't intersect.
Yeah, and also we don't really know what to do with it. So if we start with very simple things that work very well, people will understand how powerful it is.
And we're gonna try to gain the trust, because as you say, there is a community that say no, we don't trust this.
Yeah,
we want to have a human model better.
Yeah,
but I think there is some trust to be gained there.
I mean, it's for me also for implementing tools on satellites, because when you see the last missions, it's always the same set of instruments, and we don't really take a lot of risk.
Yeah.
And naively, I was like, you can get data in the satellite and bring that. Just accessing the data is a risk, and you need. It costs a lot actually. You need double wires, or I mean, that can be very complicated.
Yeah.
And then when you propose a mission, you have the choice to propose an instrument that will be accepted, that works, that maybe has a better resolution, and something completely new with something automatic in it. That can be scary also for the agencies, I think. That's why I thought that to put the final decision to human or a way to shortcut it if it doesn't work is very important, at least at the beginning, or
Yeah. Or in the beginning, we could have a hybrid setting where we can keep some, let's say, small overlap and see in operational point of view, if you have two systems doing the same thing, we can see over time if actually have similar outputs. But of course, if you have overlapping tasks, then you need more resources because you cannot have, let's say, two instruments doing the same thing, right?
Yeah.
So we have to find this balance. But I think we should have a transition period, not directly go to completely new instruments or
Either you have like I don't know, a mission dedicated to that to test, or you want to implement it on a, let's say, normal mission as an improvement, and that will be maybe more complicated. And you also need the expertise. Instrument teams who develop instruments may not have they may have a very good expertise on this kind of detector, but not on machine learning. So they will require strong interaction, I think.
Yeah.
Yeah.
I had more of a comment or question. There are a lot of people working on different algorithms for segmentation kind of problems. So in heliophysics, we have this scoreboards, for example, where there are multiple models who compare the arrival times and all that. And it's kind of, they try to bring along as many models as possible. So are there things like that for the solar physics community on the segmentation type of problems in machine learning? Because there are multiple.
As I mentioned before, there's a 2 years ago they released a benchmark dataset, and people like Simon presented earlier, and I will try also to experiment that. People try to submit many to use this dataset over various algorithms. So this is one way to benchmark.
So, okay, this was specific to solar physics community?
Yeah, it was a segmentation of coronal holes. I don't know if it's only coronal holes and active region, probably. Yeah. So it was 29 SDO images, 4K by 4K. So they kept the whole resolution, meaning that if you are working with smaller dimensions like me for the SCSC, that you need to interpolate a bit your mass, then you're losing some points probably. But I think that was one of the main efforts to gather and try to compare all these methods to specific data. So that's one example. But
that's more images. So we still have in situ time series. So it would be good to have some, because in heliophysics we have the kind of CCMC hosts that kind of a benchmarking thing, so where we can compare things. We would need a place where that would be compared, because otherwise it's scattered around on different papers, and it would be good to understand, okay, we have this method, it works like that. We have this method with this data, it looks like that. So that would be something useful.
Yeah.
Or maybe even it just, my head suggests fly to propose the EC team, which would make the review paper gathering all, let's say, present in methods and on different heliophysics data, like images and in situ time series. So that would be something which would be, I think, probably well accepted and very useful to have.
And under this context, keep your antennas open. Enrico didn't mention it, but he mentioned when we were close in Madrid, the Melilio, that they are aiming to get funding from NASA to have a big competition, like CAG competition, so with money as prize. So do you remember exactly the details? But I think
but it's probably like.
So it's gonna be probably, I think, something between magnetograms and L1, ASL1, or actually no, projecting the velocity. I think the velocity was the main factor.
Okay.
I think something like that. So velocity to get the regression problem, to solve the regression problem, velocity at L1.
Okay.
No, basically starting from what you see on the sun, you want to predict the velocity in the next 3 days. That's the competition.
But what would be the test set? Is it gonna be like always unseen data?
So they will try to have a very fair. So they will provide in chunks some training, and then people will have to submit their algorithms, their models, and then there's going to be a private test set that's going to be run only by the the organizers of the competition. And perhaps every 6 months they're going to have a new slot, not still a final. So that's why perhaps they didn't advertise it. But that will be a nice opportunity to people to submit various models, known and not known right now, and to have a stage where everything will be somehow equally compared.
Yeah, and
This the Kaggle competitions are really popular in engineering.
It's also in the magnetosphere community, the GEM challenge that happens. Basically compare magnetosphere models, mainly in US, but
in climate they were doing hackathons where they would like create proceedings and publish it. So everybody who participates in a hackathon is submitted as a co-author to this proceeding. And you get a publication.
Usually after these competitions, there is a big paper coming, and where at least top 10 or top 20 they contribute, they present their models, and then there is the competition organization that they actually plot the results. They do, and I remember during my biomedical engineer path, travel during my PhD, it was a similar competition where the organizers, they tried to make the best model by combining these models. So in the end, they took the top 5 and they did all the possible combinations. And they concluded that the best possible model for this specific test set would be this. That was very interesting. And everything was open source. So actually, this also, I think, will be the case that for this competition, you have to have your code open source, but there is a small loophole there. I think he said they were going to provide some data, but then you're free to use whatever data you wish, which in some fields, this can be a loophole because anyone can use whatever data to do training, and data is sometimes decisive. It's an important factor of the behavior of the model.
I mean, I would like to backpedal a little bit and go back to Yasmina's ICC team proposal. I mean, remember that Enrico said that we need a new review of the situation because his is from 2019. Honestly, and especially for the European community. So this will be really cool if one can do that, and then one writes a large review.
I think the call will be soon out.
Really?
Yeah. So just because I know we have usually reviewing in November or something like that.
Which
EC. This is EC.
ECBEM Space Science Institute. International Space Science. All right. I thought European Commission.
There are usually calls for
the same
teams. They can be also workshops. So there are different options for financing. That this is financed. Then people are financed to come there. So you pay yourself a trip, but the hotel and the daily expenses are paid there. And then usually for the teams, you have like 2 weeks of in 2 rounds, let's say 2 weeks of meeting, and then it's really awesome because then people can discuss and you select the tasks which will be done, who will write what, and then the review paper can be prepared for that because I think it would be very useful to have one.
Problem is that what Enrico said, that there are so many papers, and you have to be able to filter the interesting. I'm not saying the good and bad. I'm saying the interesting ones.
This is exactly the point
for a group which
doing only
dedicated doing that.
Yeah. So, and this is usually you have like a year and a half, 2 years to handle that. And if you decide to do that, I can slightly help because I am in the selection committee. So I cannot, then I have to go out when the project is being discussed, but I can help and give tips for writing it because I've been doing that for several years already. I know how it works. And I think really it's an excellent platform to do something like that because with the very fast development in the field, things get, scattered too much around. And such a paper, which would be done kind of focused and we try to make it fast would be a really good thing.
I only found the early,
Yeah, it should be soon out because
soon it will be out, the
yes, it should
deadline.
be soon issued. Yes.
You should, okay, then I will.
Even the call,
looking
we don't-
for-
Yeah, the call. Yeah.
Starting with just a letter first and then
No, it's a full project.
full project.
But that's not large because it needs to discuss, I mean, all the expertise and who will do what. In principle, kind of like, I will be in charge for this, he will be in charge for that. And then it's usually like 4 pages projects
It's short.
for the teams. This is short. If it's focused up to the point with well-defined goals and stressed need for that, I think it has a good chance to be selected. And it should be a balanced international team, balanced versus the old and young people. I mean, it's like senior and even PhD students can be
I think
invited.
you can invite them, yeah,
Yes,
after.
additionally, yes, and mention that they will be invited, and also has to be gender balanced because these are usually there is a lot of competition. Last time were like 60 proposals, and from the heliospheric part we had like 15 financed, which is not bad rate, but it's there was much more submitted than previous calls.
Mhm.
But the point is, in such a case, it's very important that you have all these small things which then will wait out, like a balance of gender and things. Because if there are many good proposals, then these small things will
They matter.
wait out. Yeah.
The balance of countries also.
Balance of countries, yes. And it's also good that it's not only European thing, but you have also someone from US, someone from China. Diversity is considered as a beneficial.
And 2 PhD students, not something like that.
Yeah.
Because I already joined a team, and it was for 3 years. I went to Bern, and it was very good.
Yeah.
Very good.
Platform, it's very like fruitful.
Yeah.
The call is not yet out.
It doesn't matter. I couldn't find even a page referring to this program.
ISS Bern dot
Yeah.
Yes, because you're saying,
I,
It's
like E, like,
Yeah.
sorry, I.
yeah.
Perhaps you can put the chat for the people here.
Yeah.
Hi, I'm not in the stream.
It's nice institute.
I sent you
Let
by
me,
mail early in the morning. So if I
we will do something very
Hi,
exciting,
yeah.
right?
send to me and I will.
I mean, in principle, as a committee member, I should get the announcement that the
Yeah.
call is out. So when I get that, I'll inform you guys. I mean, I'm here, so just because did you get something from them?
So it's this one. I also have it in the screen.
Yeah.
I think it's a very good platform, and usually there are not too many AI-oriented heliophysics proposals as such, because if there are many which focus to the same topics, then
And there,
it's more critical to get it.
in a real bit, it's a tool that can be useful for what I
Well, it's better to be focused, huh? If we want to have a paper, then it's a review paper. It's a review paper. So
Yeah.
Overview review paper may be promising to get some kind of platform somewhere where the results can be put, something like that. But when it comes to that, I think.
Yeah. I will have participated briefly to a systematic review. It's a lot of work. Because you just do a specific moment, a search to Web of Science, and you have very strict criteria how to select, how to do some small filtering. And you have a bit to sort them based on categories. And then you have to have at least 1-2 paragraphs for each one and have a contribution.
This is why you
Yeah.
gather the experts from different countries on slightly different things, and then you discuss on spot and you split up the
Yeah.
work. I mean, I was just now in such a.
Yeah. Another topic that perhaps inspired you and you have some comments. Yeah, any
Yeah.
suggestions how perhaps ASAP would go on. We also had some very, very preliminary discussion, which is very, very preliminary, of course, how we could proceed in the future. I mean, you got a small overview of what we did in ASAP.
Yeah.
And of course, we need somehow to find new direction if we would like to do something else in the future. We shouldn't do the same thing.
Perhaps it was worth mentioning that at the end of ASAP, it's going to be TRL4 level reached for the development.
Mm.
Where to move from there.
Yeah, of course, you have to see the actual results.
Yeah, the evolution where should it go?
So to me, it seems like we have to have even more sort of this engineering aspects if there is a future proposal, but to keep maybe some basic research as well, which goes side in side with it.
Yeah, because
yeah.
Our field is very dynamically changing. I mean, in the future, I think we should somehow be able to incorporate more sophisticated algorithms like attention, like foundation models. Perhaps in the future might be more in the use. So we shouldn't just consider the very, very, very simple and traditional algorithms that they work now. But in 10 years or in 5 years, we're going to have something different state of the art. So we should have still a scientific panel to have it then open and be able to find these algorithms and then do a selection which have the possibility to be ported and transferred to the engineers. But yes, again, we're gonna be the ones that we're gonna bring more algorithms, and engineers will say we don't need more algorithms. We need to have less algorithms to and I understand that. Yeah.
This is why you need a review, and then you make a review and you make kind of like a scaling what is better and what could be combined, and then this is the path towards the.
Yeah.
Then you apply for a new project, ASAP 2, and then ASAP 2 refines what will be given to. And I was just saying to Katya that probably if when is the finishing next?
We have 1 year.
We have 1 year to go, and we must
Perhaps there might be
extension.
Yeah, perhaps we're gonna be.
It's gonna be like March
Applying
27.
now in the next upcoming call would be a good thing, because you could also say that the expertise and the work which was here, that it can be directly inputted to the EC team.
Yeah.
Can I say?
It will be both.
Please go.
Yeah, just well, I don't know if it's a good idea. Just throw it out there, and then because if the objective is maybe to let's say go a bit more on the practical side, on the engineering side, maybe an idea just to test could be to implement something as a baseline on an FPGA or something like that, and to test in a plasma chamber. Because I don't think in like 1, 2, 3 years you can have a CubeSat, for example, to test an algorithm, but it is absolutely possible to do it on.
But if I remember correctly, there is an FPGA that has been approved under proper sealing.
Yeah, like hardware.
Yeah, I think.
Yeah, not in terms of environment, but radiation, because that you cannot do.
Okay.
I mean, in terms of algorithm, something like I'm imagining. I have a magnetometer. I want to select when I have certain waves. So I place my magnetometer with my FPGA with the same algorithm, similar. That I want to develop, I place it inside my plasma chamber, and then I have an antenna on the side that. Something like that, which is maybe a bit more not very realistic, but a bit more realistic.
Yeah.
Maybe a step that takes 1 year. I mean, maybe 2, but less than.
That's interesting. Yeah.
I say that because maybe these kind of ground facilities maybe are not something that the one immediately thinks about. But
it's
I don't know if it's point of view how feasible is, how the budget wise, how much needs how much budget needs
to rent a plasma chamber like that. It's I think 20,000 euros for a week, maybe something like that. So I think with 10, 20, 15, that order of magnitude, you can rent it for 1, 2 weeks. I mean,
something to be considered for sure.
It's a bit of an investment, of course, but I don't know about the, let's say, how the development beforehand, like how much would it cost to pay an engineer to develop to port the algorithm on these kind of things.
Yeah.
I don't know.
Yeah.
Perhaps Pedro.
I just know that you can also test on Earth you can throw a bunch of radiation onto. There are test facilities to throw a bunch of radiation into the FPGA to test the radiation.
Yeah, for me, it was not the testing of the algorithm,
Yeah,
was the testing of the algorithm.
yeah.
Okay.
All right. Any last remarks?
I think we're close to the end, so we should probably start. Yeah, I will just add maybe that, it's not something that hasn't been done, right? There are cases of, there was this satellite Demeter where they actually used neural network to basically estimate the number of whistlers. Because for the same reason, they could not downlink all this information. They could not downlink the wavelets, where you would use it to normally identify the whistlers, but they did it on board. And this was done some years ago. So it's possible.
Demeter mission was also Taranis after it was a small CNES mission, French mission. And I feel like they had a lot of freedom.
Yeah.
I don't know if we still have the same, but it was nice missions.
I don't know, from the people online, any last remarks?
My side.
Okay, then we should probably close. It was a great workshop, many interesting discussions. So I hope we'll do the same thing next year. Something like this.
But longer.
But longer, yes. Yeah, because this one was not long enough.